This is the story of a passive house and passive house accessory dwelling unit in Berkeley, California. My wife and I moved back to the San Francisco Bay Area in 2010. Our primary criteria was a house and extra space with good southern exposure so we could build a passive house and my wife could expand her garden. We found a perfect house in northwest Berkeley in the poorly named Ocean View neighborhood. It's full of 1940s housing for the World War II workers that were building ships in Richmond, California. There are dozens of houses with the same floor plan, only reversed from one lot to the next. As we've done several times over the past 30 years, we bought a fixer-upper with the intention of doing a gut remodel. As it turned out, we first built a 300 square foot passive house accessory dwelling unit, or ADU, completed in 2015. We then prepared our plans for the remodel, moved into the ADU, then built the modest 1,000 square foot home. In addition to being passive house, both buildings are net zero and LEED Platinum certified. Living in the ADU during construction made it very easy to do daily on-site inspections and resolve problems as quickly as possible. Because of zoning restrictions, our footprint remained essentially the same as the original house, with a small kitchen expansion and deck in the rear. Window placement was informed by a combination of PHPP calculations and shading studies. We turned the one bedroom, one bath house into a 2-bedroom, 2-bath house plus an office. The modern design includes 10-foot ceilings to accommodate clerestory windows in most of the rooms. We focused the primary and living areas into the back of the house facing the garden and the passive house ADU, reversing the traditional neighborhood pattern. We dropped the ceiling in the second bathroom to accommodate the HRV and in the main hallway to provide a place for the HRV ducting. We approached the construction of the house the same way we approached building the ADU. Build an insulated balloon, foundation first. Because we're in a liquefaction zone, we needed an 8-inch thick slab on grade, wrapped in 2 inches of vertical insulation. This was topped with 3 inches of rigid insulation and then a 3-inch radiant floor slab. The next stage is framing. The advanced framing walls are predominantly 2x6. The roof is 2x12 TJIs. Next, create an airtight shell with only a single door opening, covering the exterior sheathing with air and water barrier on all sides. And do a blower door test. Celebrate, hopefully. Then cut in the doors and windows, making sure to seal all the penetrations. Do a blower door test. Rough in all the plumbing, electrical, and mechanical, and air seal. Blower door test. Insulate, and you guessed it, another blower door test. Finish up the interior and exterior and do the final blower door test. This approach lets us identify and correct problems early and gives us a good idea of the effect of the various construction layers on the airtightness. The walls have 2 inches of exterior mineral wool, ventilated siding, and perimeter venting all around. The roof is capped with sheathing, 2 inches of mineral wool between ventilated overhang framing, a second layer of sheathing, and the finished roof. The siding ventilation carries up from the foundation to the roof framing. This combination of exterior mineral wool insulation and ventilation creates a thermal bridge-free shell with excellent vapor permeability. The all-electric house has very simple mechanical systems. There's an HRV providing filtered fresh air throughout the house. This has been especially useful during the recent fire season. By changing the filters every 3 to 4 weeks, we've been able to avoid most of the respiratory problems that thousands of others have experienced. Because of the highly insulated and airtight envelope, the interior temperature remains between 68 and 77 degrees throughout the year. The radiant floor heating only turns on for an hour or two for just a few weeks in the wintertime. It's powered by a small 7 kW instantaneous electric water heater. The highly efficient heat pump water heater, induction cooktop, refrigerator, condensing washer dryer, and LED lighting make it easy to achieve net zero electricity consumption with a modest 3.2 kilowatt solar PV system. One benefit of pursuing LEED certification is that system's emphasis on recycled materials, reducing the building's carbon footprint. We deconstructed the previous house and recycled most of the materials. saving quite a bit of the old framing lumber to build some interior furniture, an ongoing pandemic project. The concrete has 30% recycled content. The interior blown-in mineral wool has in excess of 50% post-consumer recycled content. The cementitious siding has a minimum of 70% pre-consumer recycled content, and the deck is 100% recycled bamboo. In the end, we have a fantastic, low-maintenance house with outstanding interior comfort, even during heat waves and fires. We have essentially no utility costs. The fruit trees that we planted before construction started all survived and matured. There's plenty of room for raised beds for edibles, and we get to look out the backyard at our Passive House ADU. After living in the ADU for 2 years and the main house for an additional year and a half, it's clear to us that Passive House is the only sensible way to build.